Okay, so this was a particularly challenging kind of area and volume / geometry question. So what you have here is you've got a regular tetrahedron, has 4 faces. So if it's regular, for starters, you know that all of its sides are the same. Okay, each of which has an equilateral triangle. A wooden puzzle consists of several pieces that can be assembled to make a rectangular tetrahedron. The manufacturer wants to package the assembled tetrahedron in a clear cylindrical container with one face flat against the bottom. If the length of one edge of the tetrahedron is 2a, show that the volume of the smallest possible cylinder container is 8√6/9 pi a cubed. Okay, so first of all, I'm looking for volume, and I'm looking for volume of a cylinder. So volume of a cylinder is equal to pi r squared h. Okay, so I'm looking for a number of things here. I'm looking for the radius, and I'm looking for the height. Okay, so once I have those two things, then I can start forming an equation for volume. Okay, so the first thing I'm going to do is I'm actually going to look down on this way. So this is one of the probably frustrating elements of area and volume or geometry, in which you have to be prepared to look at it in different ways. So particularly difficult one, I'm going to look at this face down. Okay, so as if I'm looking in at the top. If I do that, I get a circular shape, okay, with a center point. So the point of the triangle is in the center. Okay, and I get, okay, now this is the center point. Okay, so if I like this, and this, okay, they're all radius of the circle. So they're all identical, and they're all the radius, or. Okay, so let me just go through that again. I'm looking down on top of it. This point, okay, is the very center of the circle. Okay, so it's in here. So if I draw my triangle around it, okay, remember it's an equilateral triangle, so all of its sides are equal. Okay, this is my center point, and the green lines here represent the radius of this circle. Okay, because they're equidistant from the center point, which is the part here in blue. Okay, so they're equidistant from the center point to the circle in each case. Okay, so with that in mind, okay, I'm going to look at a specific triangle here. Okay, so let's go for red, back to red. Okay, now bearing in mind that I actually can do this using non-right angle triangles, but we haven't got that far yet. So let's look at it using solely right angle triangles. For starters, if these are all the radiuses, then these are all isosceles triangles. So that angle and that angle are identical. And given that these are all identical triangles, okay, because the sides are the same, so that's the same as that, the same as that, and I know already that the other sides are the same, so by SSS, okay, these are congruent triangles, which means that that angle, and that angle are the same. They're in a circle, so they all add up to 360, which means, let me just do a little bit of rubbing out here. Okay, which means this angle here is 120 degrees. And given that it's in an isosceles triangle, and all angles in a triangle add up to 180, this has to be 30, and this has to be 30. Okay, now, because I know that it's an isosceles triangle, okay, I know that I can cut it down the middle, okay, to form this right angle triangle. Okay, so now I have a right angle triangle up here. So I'll draw it in the same orientation as I took it. 30. Okay. Remembering that originally all of these sides were 2a. Okay, I've just taken exactly half of that full triangle here. Okay, if I look at that triangle, I've just taken exactly half of it. So this bit from here to here is a. So there. Okay, and remembering, I'm going to go to my highlighter now. So from here, why is that not working? Going back to my pen. Okay, I'll go for a yellow. From here to here, okay, is the radius. Okay, sorry, I've got this labeled slightly wrong here myself. Okay, sorry, A should be here. Apologies, I've kept it in the same orientation as here. So A should be there. And let's go back to this one was the radius from here. Okay. So with that in mind, I can use my knowledge of right angle triangles. Okay, so label this as hypotenuse, label this as adjacent. Okay, so I can use cos of 30 is equal to the adjacent, which I know is A, over the hypotenuse, which I know is OR. Okay, a little bit of rearranging here gives that OR is equal to A over cos 30. Okay, and again, when I gave you these, we were still on area and volume. We hadn't quite done trigonometry, but this is junior cert trigonometry. So this is trigonometry that you should have been able to do. Cos 30 is root 3 over 2. So we have A over root 3 over 2. Okay. You can go straight and say then that this would give you 2A over root 3. Okay. Or if you want me to do it out long, just to show you where I'm getting that from, A over root 3 over 2 is the same as saying A divided by root 3 over 2. There is no division of fractions. So A multiplied by the inverse 3. A times 2 is 2A over root 3. Okay. So that now gets me that my radius, or, is equal to 2A over root 3. Okay. So I've got my radius part. Okay, now I'm going to go back to my 3D shape. Okay, I know my radius. Okay, I actually also know this line because remember it's a regular tetrahedron, so all of its sides are exactly the same. So 2A. And this red line here, okay, is a right angle because it's up straight. Okay, so this triangle here is actually a right angle triangle also. Okay, I'm going to go for black now. So let's look at inside the 3D shape. I have a right angle triangle in which I have a height, a side length, which is 2A. Okay, and you were told that all of the sides of length one edge of the tetrahedron is 2A, but remember it's regular, so all of them have to be exactly the same. So in a regular tetrahedron or any regular shape, regular 3D shape, all of the sides, 2D or 3D shape, all of the sides are the same length. So 2A, and then this one would be my radius. Okay, so looking back here, and it's all just about connecting. This is hard to see, and it is just with practice. Okay, so I can use Pythagoras here. I can say 2A squared is equal to h squared plus 4 squared. That will give me 4A squared is equal to h squared plus 4 squared. H squared is equal to 4A squared. Sorry. Yeah, is equal to 4A squared minus 4 squared. H is equal to root 4A squared minus 4 squared. Okay. Now, we can look at this actually as a difference of two squares here. Okay. We can say root, actually we don't need to, sorry, I'm just overcomplicating things there. Okay. And now I can go into my volume is equal to pi r squared h. Okay. Actually, sorry, I'm going to go back up here because rather than complicating this, I actually know what or is. So let's put or in at this point. So h squared is equal to 4a squared, so 2a and a squared, minus, I know what or is. So I know or is 2a over root 3 squared. Okay, so h squared is equal to 4a squared minus squaring top and bottom. So squaring the top here would be 4a squared and squaring the bottom would be 3. Okay, so h squared, if I just get one expression here for h squared, is going to be, if I get a common denominator of 3 here, it will be 12a squared minus 4a squared. H squared is equal to, and h then is equal to square root of 12 minus 4 will give me 8a squared over 3. Okay, so now I know my radius, okay, which is 2a over